Good morning. This is Kushmar, and I am a part of Almabetter called Ground. This is module's second project of full stack web development. Here is design and analysis of algorithmic question. We have to solve and fix the problem. So let's start with question number one. So we have to explain total five questions. Question number one from code bug fixing. Question number seven from alternate code implementation. Question number 11 from logical building. Question number 16 from analyzing code. And question number 21 from first and test case. So total we have 25 problems. I have selected one problem from each set. So let's start with question number one. In this question, this could define a JavaScript function called isPower of 2 that takes a single parameter n. Here's a breakdown of what the function does. N is greater than 0. This condition checks if the input n is greater than 0. This is the first requirement for a number to be a power of 2 because all powers of 2 are positive. If n and n minus 1 is equals to 0, this equals check if n is a power of 2 in binary representation. A power of 2 has only one bit set to 1. When you subtract 1 from a power of 2, all the bits to the right of the only set bit become 1. Therefore, when you perform a bitwise AND operation between n and n minus 1, the result will be 0 only if n is a power of 2. So, the console.log is power of 2 64 statement then calls the is power of 2 function with the argument 64 and logs the result to the console. In this case, since 64 is indeed a power of 2, 64 is equals to 2 to the power 6. The function will return true, indicating that 64 is a power of 2. Now, I am explaining the question number 7 from alternate code implementation. In this question, we are improvised to the coding problem. They have already given approach one for solving the problem. They are asking to provide alternate solution for this solution. So I wrote the second alternate approach by two pointing approach. In this code, I have taken a function that is palindrome parameter of n. I have just used n dot string here to convert tid number to string and pointer initialize that is left and right. Here is one condition used if right is a greater than left and inside that if a string number that is the string in the left is not equal to the string at right, it is going to throw. The output is false simultaneously here left. It will check every character it is fulfilled condition. It will return true otherwise false. Let's take an example. Let n is equals to 1, 2, 3, 2, 1. Its output is 2. If n is equals to 1451, its output is false. And n is equals to 1, 2, 3, 4, 5, its output is false. Now I am explaining the question number 11 from logical building. Here the question of logical building, question number 11. The JavaScript code define a function find peak elements which takes an array nums as input and return the index of any peak element present in the array. A peak element is defined as an element is greater than or equal to its neighbor. The function uses a binary or search approach to efficiently find a peak element. It initializes two pointers, left and right, at the beginning and end of the array respectively. It then enters a while loop while it continues searching until left pointer is less than or equal to the right pointer. Within the loop, it calculates the middle index mid of the current search spaces. It then checks if the element at mid is greater than or equal to 0 or equal to its neighbors. If it is mid is a peak element and the function returns its index. Then, if the element mid is not a peak element, it checks whether the element of the left of mid is less than the element mid. Lastly, the code includes two function calls to demonstrate the uses of find peak element function with sample input array and prints the result with console.log. Find peak elements on 1, 2, 3, 1. Its output is 2. And again the console.log find peak elements 1, 2, 1, 3, 5, 6, 4. Its output is 5. Because your function can return either index number 1 where the peak element is 2 or index number 5 where the peak element is 6. Now I am explaining question number 16 from analyzing code. In this question, we have a two approach, traditional approach and optimized approach. Firstly, we will explain the traditional approach. In this traditional approach, to find the missing number in an array, first construct a hash set to store all elements of the array and the interacts throughout integers from 1 to n. Checking if each integer is missing, it returns n plus 1. But in optimized approach, utilize cyclic sets. It iterates through the array, planning each element in its correct position by swapping it with the element at the index equal to its value minus 1. After sorting, it iterates through the array again, checking if element is in its correct position, that is, if array of I equal to I plus 1. If not, it returns the missing number, or if no number is missing, it returns n plus 1. The optimized approach has a time complexity O of n and doesn't require extra space like the hash set, making it more efficient than the traditional approach, especially for large arrays. Now I am explaining the question number 21, worst and best case. Now firstly we will explain the worst case. It iterates through each pair of numbers in the array using nested loop. For each pair, it calculates the bitwise AND of the two numbers. If the bitwise AND value is greater than the current maximized bitwise AND value, max bitwise AND and not equal to the maximum integer value, max integers, it updated max bitwise with this value. Finally, it returns the maximum bitwise AND values found. In the best max bitwise function, it also iterates through each pair of numbers in the array using nested loop. For each pair, it's checking if both numbers have a leading one bit at the same position in the binary representation. If they do, it calculates the bitwise AND of the two numbers and update max bitwise. This value is greater than the current maximum bitwise AND value. Finally, it returns the maximum bitwise AND value found. The code then provides two examples, example 1 and 2 array, and the compute the maximum bitwise AND value using both approach for each example. It prints the result using console.log. The best bitwise function is more efficient because it avoids unnecessary bitwise AND calculation by exploiting the function that the maximum bitwise end value occurs when both numbers having a leading one bit at the same position. At last, we will try to show the example const output 1 best max bitwise example number 1 2 3 4 5 6 console.log output 1. So we are explaining 5 questions for second module. I hope you like it. Thank you. Have a nice day.